Good afternoon, everyone. This is Elisa Baum. I'm GridGain Systems Director of Product Marketing. I'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? Let's see. Do you guys hear me? Yes, you do. Great. Next, during this webinar, you will be on mute. And should you have any questions during the discussion, and I am sure you will, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible, and those that aren't addressed, I'll forward on to Dennis, our speaker, who will address them in a follow-up blog entry on GridGain's blog. In addition, a recording of this webinar and the slides will be made available to everyone within 48 hours. So with that said, I'd like to thank you for attending today's webinar, Apache Ignite, a backbone for microservices-based architectures, being presented by GridGain Systems Product Manager, Dennis Magda. And with that said, Dennis, I'll turn the floor over to you.
Hello, everyone. Thanks, Elisa, for the introduction. And today, guys, I hope we are going to discover more new cool features that are available as a part of Apache Ignite in-memory data fabric. And in particular, we are going to plunge into the topic of Apache Ignite Service Grid. I think that most of you, and it was assumed that most of the attendees already know about what Apache Ignite in-memory data fabric is. So we are not going to spend a lot of the time discovering and learning all the basic information about the product, and we will start with the service grid almost immediately. So service grid is actually our foundation. It's Apache Ignite's foundation that might be used as one of the kind of foundation for your microservices-based architecture. And then after we just spend a couple of minutes looking at the main features of service grid, we will move on with with an overview of microservices-based solution for Apache for your application based on Apache Ignite. And as a part of this proposed solution, you will see how you can define special sort of cluster nodes called data nodes and service nodes. I will give you some my personal understanding on how the nodes can intercommunicate with each other by means of service grid APIs or other communication protocols. Also, I will give a couple of suggestions on how your applications can interact and connect to your services. We will take a look at so-called internal and external applications. And finally, the final topic related to this proposed solution will be about the persistence. So what if you want to persist your data and survive cluster restarts? Here is I also will just give you a general overview and guide to, and will refer to an existing kind of existing information available in different Apache Ignite resources. And we will end up our webinar with demo. So I like demos. I like to demonstrate all the theoretical thing we are trying to to convey over our webinars. And this is why I prepared a special project with templates that is based on the solution, on the microservices-based solution we are going to discover. And then at the end of the webinar, you will be able to, to download it and to play out with it offline. Okay, Apache Ignite Service Grid. Just in any case, just to make sure every one of you is aware of what Apache Ignite in-memory data fabric is, I will just spend a couple of minutes listing our major components. So first of all, Apache Ignite in-memory data fabric is a distributed platform that allows you to interconnect your machines located in different environments using our advanced clustering component. And so once your cluster is up and running, once every machine discovers each other, you are able to interact with this cluster. You are able to leverage from this cluster. And the first thing you can do, and you basically will be doing, is you will be using our data grid. Data grid is a key value storage, is a distributed key value storage that puts out all the data across all your cluster nodes available. And on top of this data grid, you can, once your data is in your cluster, you can talk to your data using multiple ways, like basic key value operations or transactions, or you can stream data there, or as SQL Grid component says, you can execute SQL queries on top of it. And SQL Grid is built on top of data grid because it needs to know the locality of data. It needs to know where to send your SQL queries. And as for SQL queries, we do support, just to refresh your knowledge, the SQL Grid is NC99 compliant. It supports distributed joins. It supports data modification language. And pretty soon, once Apache Ignite 2.0 is released, you will be able to use data definition language as a part of SQL Grid functionality. As for the other modules, for sure, you can execute your distributed computations, which are embedded in our compute grid. For those who are interested in streaming, you might take a look at our streaming capabilities, but the main topic of today's conversation is service grid. So, and as for service grid, basically, if we, let me switch to the next slide. As for the service grid, actually, it's a special API, straightforward API, as you see pretty soon, that makes it feasible to write any services you like and to deploy them in your cluster, in your Apache Ignite cluster. As for the deployment and life cycle of your services, it will be a burden of Apache Ignite in-memory data fabric to take care of this. Actually, the only thing you need to do is just to implement your service and provide a service configuration for it, and that's it. After that, the service will be deployed in your cluster automatically for you. It will be all the requests to your service will be load balanced if you have multiple instances of the same service deployed. Also, you don't need to care about fault tolerance. If some unexpected situation happens and one of your services goes down, it will be automatically redeployed on other machine. As for the configuration, I said that you just need to implement your service. That will be the first step. And the second step is to provide a service configuration. As a part of the service configuration, you just basically say that you want to have, for instance, a single instance of the service deployed in your cluster, like it's shown on this picture, where we have 4 cluster machines, but a service instance is deployed only on a single machine, which means that if this machine goes down, the service will be redeployed on other machine that is applicable for the service deployment. Or you can say that, for instance, I want to deploy a service instance on every individual machine. We call this sort of deployment cluster singleton deployment. And the cluster singleton deployment is exactly shown on this picture. But for instance, if you want to make sure a service instance is deployed on every node, you can define so-called nodes singleton deployment. And then the same service, will be deployed on every machine you have in your cluster. These are 2 default configuration parameters. But for sure, the configuration characteristics of service grid are much more flexible, and you can design and implement in live insane configuration deployment, insane kind of deployment configurations, everything that you need for your own business use case. Next, to talk a bit more about deployment stuff. As we see on these pictures, basically, if to talk about this node singleton, you can see that the node singleton, a specific service, was deployed on every node you have in your cluster. But for instance, what if you want to make sure the service is deployed only on a subset of the nodes you have in your cluster? Let's say you want the service to be deployed on that node only, and the service must never be deployed on the rest of the nodes. How can you do this with Apache Ignite? The answer is simple. So you should use special class called node filter, and the node filter will follow your kind of node filter is just a piece of is just your implementation, and according to your implementation, the node filter can decide that, let's say, the service should be deployed on this node only and never be deployed on the rest of the cluster nodes. This is about deployment, and today I will show you how you basically implement these node filters and how they help us, to make a subset of the nodes that will be so-called service nodes, and only those nodes will be eligible for further services deployments. Next, once your service is deployed, how do you interact with your services? The most straightforward approach is again to rely on service grid APIs. Specifically, you need to use, for every service, usually when you implement your service, you define a unique interface for it. And then you can reuse this interface from the side of your applications or from the side of other services when they need to talk to a specific service. So what you need to do, you just in Apache Ignite application, you just take this, you just create so-called service proxy, and you pass a service interface to this proxy. And after that, Apache Ignite Data Fabric will automatically look up a node where the service is deployed, and it will redirect all the queries to that node where the deployment, where the service is presently deployed. Sticky and not sticky is related to load balancing. So basically, if you create a sticky proxy, kind of a sticky connection to one of the services deployments, it will mean that all the queries from, let's say, from your application will go only to one of the nodes where the service is deployed. But if you choose so-called not sticky proxy, and if you have more than one instances of the same service deployed in your cluster, then with every request to this service, the request might go to any node you have where the service is deployed. The other cool thing about this manageable deployment and service grid requests is that you don't need to have services implementations on all of the nodes in your cluster. Just keep this in mind. The services implementations must be located only on the nodes where the service might be deployed throughout the life cycle of your data grid, throughout the life cycle of your overall application. For the rest of the nodes you have in your cluster, you don't need to have services implementations there. But for instance, if you're going to interact with your services, let's say from your application sites, then an application just needs to have a service interface in its local class path, and it doesn't need to have a service implementation. This is one of the major points you just need to keep in mind, because we use it as a basement for our microservices architecture, the suggested microservices architecture. We are going to review just in a couple of seconds. Okay, so but before we just switch to the review of this microservices based architecture, let's just try to recall some of the common pitfalls you might face with if you're trying to build a microservices solution. For instance, you should care about the life cycle. Someone should initiate your service executed and canceled when it's no longer needed. Plus, if you deploy multiple services in your cluster or even with a single service, you have to deal with load balancing and fault tolerance, right? So, because if one day a service goes down, you want to be sure that the service is up and running, preferably in a minute or so. As for the load balancing, if you just decided to have multiple instances or the same service deployed in your cluster, then it will be cool to make sure that the services, all the instances of your services are properly loaded, so that all the services, all the requests are going to all the services you have. Next, as for the scalability, right? So let's say that you expect the load, your solution kind of struggles with significant load, and you want to somehow to scale out somehow. You want to tolerate this load. And here is, you just need to think of how you will do this. Is if, for instance, let's say on some holiday, more customers visit your site, and now you just need instantaneously scale out your microservices-based solution, making sure that your offering doesn't suffer and that your customers doesn't suffer. Okay, so now we came to one of the possible solutions, microservices-based architecture. You actually might want to use in your own use cases, and the solution basically looks this way. We suggest to define to have an Apache Ignite cluster, but the cluster will consist of two major types of nodes. The first type of nodes is data nodes. Data nodes are just plain nodes that store your data in a distributed fashion. And these nodes actually, they process all SQL queries, they process different computations. So all the requests that are related to data reads or data modifications, they will go to these data nodes. However, these nodes has nothing to do with your services that are deployed in the same cluster. For the service deployments, we dedicate a special kind of nodes called service nodes. And these service nodes, on the other side, they will not store any piece of data, which means that if at some point of time you decided to upgrade to your microservice 1, you just fix some bug, then you don't need to restart your whole cluster. You just need to restart a group of service nodes where this microservice 1 is deployed or might be deployed potentially. If to take a look at this picture, let's say that you updated source code of your microservice 1, and then you need to move it, you need to publish it in production. And what you need to do, you just need to take two of these service nodes, you have to bring them down, update implementation of this microservice 1, and then put the nodes back, and they will be added into the cluster. Yes, during this time, microservice 1 will not be accessible from your application side, but in any case, what you achieved with this deployment is that you were not required to restart the whole cluster. You didn't touch your data nodes. You didn't touch other service nodes where microservice 1 was not deployed. For instance, we didn't suggest you to restart this service node that hosts microservice 2 or microservice 3. Okay, so this is a cluster. Below the cluster, if you just need a persistent storage, you can easily connect your data nodes to a storage of any kind, like a relational database or a NoSQL databases like MongoDB or Cassandra, or it can be had whatever you like. And finally, when you once your cluster is up and running and once your persistence is ready, you need to talk to your cluster by means of your applications. And your applications can talk to your cluster using Apache Ignite APIs or some other protocols, right, like REST, like plain network sockets, and so on and so forth. Okay, and now let's take a look more briefly on every individual component we defined on this suggested architecture. And let's start with the definition of data nodes. So as I said, a data node is just a, so in Apache Ignite, basically, we have two kinds of nodes. So we have special server nodes. Sometimes we call them data nodes as well, or computational nodes, as it's shown on this picture. But actually we have server nodes. And the second type of nodes, according to Apache Ignite notion, is client nodes. Client nodes are used to connect to your cluster. So like it's shown in this picture. Here is your client, your applications use client nodes to connect to your cluster. So okay, going back to our data nodes. A data node is just a server node that stores your data sets in a distributed fashion. That's it. And since all these data nodes store your data set, it will mean that when you want to update the data, or you want to read the data, or you want to send a computation that needs to pick a subset of the data and do something with it, then all the queries, all sort of these queries will go to your data nodes. And it makes sense to emphasize over here that data nodes, you can think of them as a just plain distributed storage, meaning that you don't need to have implementations for your data model classes. You don't need to have implementations for your distributed computations. And you don't need to have any other sort of your custom classes like implementations for service grid on these data nodes. That nodes will simply store your data set. And you need to restart these data nodes only, for instance, if you want to move to the next version of Apache Ignite, or you need to upgrade hardware where the nodes are running, and that's it. And how basically you define programmatically, how you define this type of nodes programmatically. A solution is pretty simple. You need to use before mentioned node filter class. It's just a basic Ignite predicate. It's a single method predicate, and the basic implementation you can use looks like exactly this way. You can say that a data node will be that node that has this attribute set in its special attributes map. And here is we have below this special attributes map defined. So this is a part of Spring XML configuration that is used to start our data node. And here, as you see, that every node that uses this configuration upon startup, it will have this attribute defined there. And then when this node will join the cluster, this filter will be triggered for it. And if the filter sees that the node has this attribute set, then the node will be considered as a data node, and as a result, we will deploy caches there. All the caches you have in your cluster will be deployed on that node as well, meaning that a node will be responsible as a subset of the data of specific caches. And the data node filter has to be set for every cache. Excuse me, I just jumped quickly in the wrong direction. This filter has to be set to the configuration of every cache you have, because it will be, it works like when you just, when as I said, when a node joins, the filter will be triggered kind of for every cache you have, and then it will be decided where the cache should be deployed on this node or not. And then at the end of our webinar, I will show you, using the demo, I will show you how basically it looks like. You will see more details how it looks like at source code level. Okay, this was about data nodes. Now let's talk a bit about service nodes, the second component in our proposed microservices-based architecture. So a service node, technically it might be Ignite server or client node. There is no any difference. And if to give a definition for this type of nodes, I would say that a service node is a candidate for a service deployment, meaning that this node at some point of time might be used as a target for a service deployment, and we want to define this specific subset of the nodes in our cluster. And once a service is deployed, as for the service deployment, if you recall the previous slide where we showed that architecture, every service node might have multiple instances of the same service deployed, and at the same time it can deploy services of different type on a single machine. So everything just depends on your configuration, whatever you like and whatever you need. And the benefit of having separated service nodes is that you can maintain them separately from the rest of your cluster nodes, from the rest of your data nodes, or from your applications. Meaning, for instance, as I explained earlier, if you update a version for service A, then you need to shut down and update only those service nodes that might be or candidates for your service deployment, or was the nodes where the service were deployed before. And that's it. Okay, how do we define a service node programmatically? We follow the same approach as we did with our data nodes. Specifically, again, we just need to create a special node filter, and the node filter will check special parameter. Like for instance, here is we define a filter for vehicle service that will be deployed in our cluster, which means that vehicle service will be deployed only on the nodes that has vehicle.service.node attributes in the configuration. That's it. And then to apply this service filter, you need to go to vehicle service configuration and to add the filters there. That's it. And it will mean that once when you start some node that have this attribute in its user attributes map, then vehicle service can be deployed on this node right away, depending on your deployment configuration, or it might be deployed a bit later if your cluster topology changes. As for the communication between your service nodes, every service node, for instance, it can call the other service, and you have, or for instance, you will have your applications, and applications also need to interact with your services deployed. And in general, there are two main approaches, two main ways how you can establish, the communication between your services, or between your services and your applications. The first one is just use so-called in-cluster communication by relying on Service Grid API. If you take a look at this, it means that by in-cluster communication means that for every service, like for vehicle service, you need to define your interface, which extends standard Service Grid service interface, and to that interface you add additional methods that are implemented, that are supported by your service. And then let's say if you have the other service or your application that needs to talk to this service, it just need to have this interface locally, and it will use Service Grid API to talk to the service deployments over this interface. And service interface has to be located in the class path of all the nodes that that can work, that might potentially work with your service. But for instance, as for the data nodes, they are free from this, so they don't need to have any services interfaces in their local class path, because we just use them for data as a data storage. But as for the implementation, a service implementation, like as vehicle service implementation, must be located in the class path of all the service nodes where the service will be deployed or might be potentially deployed. This is one of the major requirements you have to keep in mind if you decide to implement this architecture. And the other approach is based on external communication protocols. So for instance, if you have an application that knows nothing about Apache Ignite API at all, but you still want this application to go to your service and to talk to it, then you can just, as a part of your service, you can establish some REST socket endpoint, for instance, and the service will accept requests on this endpoint from your external, let's say, from your external applications. Talking about the applications, let's move to the next type. So actually, as for the applications, now we see that applications, again, they can use Apache Ignite API, Service Grid API, if they want to talk to your, let's say, to your data nodes or to your service nodes. But at the same time, let's say if you have, at the same time, you might have a different type of applications called, let's say, external applications. External applications are those like who are not aware about probably are not aware about Apache Ignite at all. So they're kind of, and they don't, you write them in a way that they stay above of your data layer architecture, above of your microservices based architecture. They just need somehow to talk to your services deployed somewhere, let's say in Apache Ignite or in other environment. And for this type of applications, as I said, you just need to open up special endpoints on the side of your services deployed in your cluster. And these services and these applications will actually will connect to these services using some other protocols. But at the same time, if you have an application that utilizes Apache Ignite APIs that connects to the cluster of your server nodes and of your data nodes and service nodes by means of client applications, then you can keep using Service Grid API right away. That's it. And final component from this suggested architecture is our persistent storage. So as for the persistent storage, Apache Ignite is presently it's in memory distributed system, and so by default all the data that is pushed into the cluster is stored in a distributed fashion in memory across all your data nodes. However, it's absolutely reasonable to have a persistent storage for for occasions when, for instance, your whole cluster goes down, and for sure no one wants to lose the data, and we want to make sure that when a cluster is recovered and up and running, we want just to make sure that we can preload the data from some persistent storage and and make our cluster available for our applications. And presently in Apache Ignite, we do have a special concept of so-called cache store. And as for the cache store, you just need to provide an implementation for this cache store. And based on the implementation, the data can be persistent in a relational database, in a NoSQL database like MongoDB or Cassandra, on Hadoop, or whenever you like. So it's just up to your imagination and up to your requirements. And once the storage is enabled, it makes sense to activate read-through and write-through capabilities so that, for instance, when a key, let's say when a key one v1 is updated on data grid level, Apache Ignite data grid will automatically propagate this update to your persistent storage, like relational database. On the scenario, for instance, when your application requests key 3 and v3, and this value is not in memory, then the data grid will automatically go to your database and will pick this key and value from there. As for the transactional support, again, if you execute distributed transactions over your data grid, all the updates will be transactional across your persistent storage and your data grid, only in condition if, let's say, if your persistent storage is transactional as well. Let's say you use MySQL, Postgres, or Oracle as a persistent storage. It means that if you execute distributed transaction, then everything will be updated in a transactional fashion, both at the level of your MySQL database and data grid. But at the same time, if you use Cassandra as a persistent storage, then updates that will come to Cassandra, they will not be transactional, because Cassandra just is not a transactional storage. This is the reason. And finally, so just to give you some insights, presently on Apache Ignite dev list, we are discussing some new cool persistent storage that will be available as a part of Apache Ignite data fabric pretty soon. And this storage will allow you, to will make it possible and not to have, there will not, with that storage, there will not be any other requirement to have all the data in memory. The storage will be used as a might be used as a superset of your data. And then you can execute not only key value queries, but even SQL queries over your in-memory data set. And if something is missing in memory, then the query will be executed over that storage. So watch on this. And so pretty soon we will release the storage as a part of Apache Ignite. Okay, so now we came to our demo. To give some overview, so basically on the part of the demo, we are going to demonstrate how to, how to implement the suggested architecture in a live environment. So, and actually I prepared a special project with templates. Let me switch from the slides to my development environment. Okay, Alisa, could you confirm that you see my source code?
I do.
That's great. Okay, folks, and here is, so this is just a tiny kind of project with some sample services. So I just developed two services, vehicle service and maintenance service. So vehicle service just works with vehicles records that are stored in our cluster, and maintenance service stores the records, maintenance records for our vehicles. An idea is simple. And here is in this application, we have several startup scripts. The first startup script, it will help you to start a data node that we discussed so far. So, and this particular data node will be used as a plain distributed storage only. So our services will never be deployed on this node. And while this node is being started, let's go to the configuration that is used by this startup script to see, to form an understanding on how we could achieve this. So the configuration looks like this way. So basically the first thing, every node that starts with this configuration, it will have the following attribute in its user attributes map. which say that this is our data node. Okay. After that, in this configuration, we define a couple of caches. The first cache, which is vehicle cache, it also enables a special node filter. And the same node filter is enabled for our maintenance cache. So looking at the implementation of this filter, we will find out that it just basically does this simple check. So it takes a node, this data node attribute from the node that presently joined the cluster. And if this attribute is equal to true, then both then both kind of vehicles and maintenance caches will be deployed on that node. On the other hand, if a node joins a cluster and it doesn't have this attribute set up, then the cache will never be deployed on that node. That node will never store a piece of data of these caches we have in our configuration. And finally, for maintenance cache, we also enabled our simple cache storage. So which will persist data. So every time when a maintenance service will be updated, we will update our simple cache storage. That's it. Okay, so now let's take a look at the output. We see that we could start our data node. It will be enough just to have a single data node for the sake of demo. And now let's move on with our service nodes. But before we move to the service node, let's take a look at vehicle service. So actually, vehicle service is just a special interface that we developed. The interface extends service grid service interface that requires us to implement just 3 straightforward methods like execute, init, and cancel. And in addition, this service is expanded with special methods that actually allows us to use it for some purpose. And if you take a look at the implementation of this service, basically what we do over here, we just at the init phase, we just saying that the service was initialized. Now it's being executed. And as for the service-specific methods implementation, here is we can see that this service presently is just a wrapper on top of our vehicles cache. So every operation like add vehicle or get vehicle, it will be forwarded to a respective vehicles cache called like put or get. Okay, and now we have a special configuration prepared for service nodes that are eligible for vehicle service deployment. So now let's start one of these nodes, and while the node is being initialized, let's go to the configuration of our vehicle service. And here is we will see the same kind of concept applied for data nodes. Here is we see that a node that will be started with this configuration, it will have this parameter defined in its user attributes map, which means that when this vehicle service will be deployed, a vehicle service filter will be executed for every node we have in our cluster, or for every future node that will join the cluster. And if the node has this attribute set in its attributes map, then the service will be deployed immediately on this node, or it might be deployed later on if topology of your cluster changes. So going back to the configuration, and why I am saying that it might be deployed later on, because as for the vehicle service, we say that in our cluster we want to have no more than 2 services instances deployed, or vehicle services instances deployed, and there should be only 1 instance deployed on an individual node. which means that, for instance, if you started 5 service nodes with this vehicle service node attribute, then the service will be deployed only on 2 of them, and the rest 3 nodes will be considered as candidates for the future deployment. Let's say if the first 2 nodes go down. Okay. Let's check that our service node, our vehicle service node is up and running. Here is we can see a special output produced by our vehicle service implementation. And now let's do the same for our maintenance service. So as for the maintenance service, again, we defined a special interface, which is called maintenance service interface. And its implementation, it's a bit more tricky. So here is again, this service will talk to the our maintenance cache, updating or getting the data from there. And at the same time, this maintenance service starts a special endpoint, server socket endpoint, that will accept queries from some remote application that know nothing about our cluster at all. And so as a part of this endpoint, we will just accept connection, and we'll return all the records using a SQL query, all the maintenance records as a part of this, while we will be processing a special request that will come to this maintenance point. Okay, so and for the maintenance service nodes, we again need to use a bit different configuration. So we are starting our first maintenance service node, and let's start the second one. Nothing prevents us from doing this. And finally, if you take a look at the configuration of the configuration, the only difference from the configuration of our vehicle service nodes is that here is we define a different node attribute, which says maintenance service nodes. And here is we are defining our maintenance service deployment configuration. That's it. And for the maintenance service, again, we need to define a special filter, which means that this service will be deployed only on the nodes that has these attributes in their node filter. That's it. Okay, so looking at our maintenance service. So I started 2 service nodes that might be eligible for maintenance service deployment. And if to take a look at the output of both nodes, I will see that the maintenance service was deployed on this node only. Here is the output. And it was not deployed on the second node. We have a single deployment of maintenance service because if we take a look at the deployment configuration for this service, we will see that we need to have a single instance of this service across our whole cluster. Well, now we have a kind of a cluster of 4 different nodes. First, we have one data node that will store all the data. Then we have a service node that where our vehicle service is deployed, and we have 2 maintenance service nodes. On one of the nodes, we already deployed our maintenance service, and the other node is just up and running. And later on, I will show how we could redeploy the service on that node when the first node goes down. Okay, about the applications. Here is some sample application that connects to the cluster using client nodes configuration. Then the node will directly talk to our data nodes because it wants to get a reference to vehicles cache, and it populates and it just pushes some data to that cache, just preloading, just putting some data there. So for sure, just using Apache Ignite API, your application will be able to interact with data nodes by means of cache-like queries, SQL queries, and so on and so forth. Then at the same time, from my application, I want to talk to my vehicle service. Here is it. So my application just need to have vehicle service interface in its class path. And after that, once I just started, then I just get a reference to this service. And after that, I'm trying to get a record for a random vehicle stored in our cluster. And this, when you execute this method, service grid will automatically find out a node where the service is deployed and will redirect this query there. And then again, we want to interact with our maintenance service. We will get a reference to one of the deployments of maintenance service, and we will try to schedule vehicle maintenance. Okay, so let's start our application. And also, as you see, as far as I remember, we enabled persistent storage for our maintenance service, which means that when we will schedule vehicle maintenance for this ID, if to take a look at the implementation, the request will come to one of our maintenance, to one of our service nodes, and when the service node does this schedule, it will update maintenance cache, and when the cache is updated, our persistent storage will be updated as well. So here, as we can see, the output of our application, we just connected to the cluster, filled it in with some entries, and then get some random entry using Service Grid API and scheduled the maintenance. And when we executed this method, finally the data, our kind of data node was triggered, meaning that this is the only node that stores all the data, and the node is connected to our persistent storage. And here, as you see, that the same value was written to our cache storage. This is how our persistent storage works. And final example I want to show you quickly is how you can work with your maintenance service using plain socket APIs. Here is I just prepared some plain Java application. This Java application will connect to this address and to this port number, and it will try to get maintenance list for all of the vehicles that might be stored in our cluster. And actually, if you recall, the service socket is opened on the node that deployed maintenance service implementation. Here is it. It means that the request will come to this node. Now let me start external test application. Okay, it executed the same query for all of the vehicles, and it found out that there is one of the maintenance records scheduled for vehicle with ID 7. Okay, and now let's demonstrate, automatic fault tolerance. Now we know that the maintenance service is deployed on this node. Let's stop this node. It was stopped. But at the same time, now if we take a look at the output of this node, we will see that the same service was automatically deployed on the second node that was in our cluster and that was a possible candidate for this service deployment. And this eventually happened. Now we have the same service up and running on this node. And if again I execute the same sample application that connects to the service using plain sockets, then I will get the same output. So nothing changes. So actually, this is a review and a template of our suggestions, or our suggested microservices-based architecture on top of Apache Ignite. And the final links, I want to show you a final slide, folks. Actually, this webinar was built on top of a series of blog posts around this topic. So you can go to, after you get these slides, you can go to these blocks and learn even more from there. And for sure, the project with the templates I used throughout this webinar is available for download. So for sure, you can go to GitHub and get it from there. And finally, if you want to read more about or to learn more about Service Grid API, go to Service Grid documentation on Apache Ignite. Okay, so that's all from my side, and I will be happy to answer on your questions.
Hi, Dennis, it's Elisa. There are some questions being asked. I just haven't come in yet, so let's give people a couple of seconds. And I wanted to invite people to register for an upcoming webinar that Dennis is doing on May 10th, and it's about real-time processing of IoT-generated streaming data. And I think that's going to be a really great topic. Dennis, I don't know if you want to give a couple of words on that while we wait for questions. But even if you can't make the date on May 10th at 11 o'clock Pacific time AM, sign up anyhow, and we'll make sure that you get a link to the recording and the slides after. And that goes for any upcoming webinar. All right, here comes the first question, Dennis. You ready?
Yeah.
Okay. How can we avoid data model classes? You mentioned plain distributed storage to store data in the data nodes. If we have an aggregate root made of several classes, how do you store it?
So there is a special concept called binary marshalling. So in Apache Ignite, all your custom objects are serialized using our own binary marshaller. And this marshaller doesn't require Apache Ignite to deserialize the data back when, let's say, a value is needed, which means that when you just put some data into your cache, your data will be serialized into binary format, and it will be stored on the data nodes. And after that, when you just need to execute SQL queries, when you execute just get operation SQL queries, you don't need to worry about classes at all, because our data grid and SQL grid engines, they know the format pretty well, and they can work with serialized data. But if you need to work with your data as a part of your distributed computations, like when you send the computation to your data node and you want to get a value stored on this data node, then you need to use, let me show you, you need to use special binary object class, which is a wrapper on top of serialized data. So if you, to be more specific, if you go to Apache Ignite README error, you need to go to binary marshaller documentation, and there you will find some examples on how you can work with the data in serialized format, avoiding deserialization on data nodes. That's all. And this binary marshaller, by the way, it's enabled by default.
Okay, the next question is for me. Yes, everyone will get a copy of the slides as well as a link to the recording after I process the event. So either tomorrow morning or maybe late afternoon at the latest. Okay, are there any more questions for Dennis? Ah, yes, we just got another one. Okay, can a service be implemented with Spring Beans?
Actually, I think that yes, but basically service implementation is just up to imagination, meaning that if you use let's say some custom library, like something from Spring, then you need to make sure that jar files of that library are added to the class path of all your service nodes where your service might be deployed.
Okay. Well, I think that brings us to the top of the. Oh, wait. You know what? You have time for one more question, I think. Do you recommend on-heap or off-heap cache for data nodes?
My personal recommendation is off-heap, because and even more in Apache Ignite 2.0, we will introduce new page memory architecture which is heap based. So in Apache Ignite 2.0, all the data will be stored in a heap region by default. With the only one option is that you will be able to enable so-called on-heap caching for your off-heap memory. But in general, yes, use of heap all the time and be ready to Apache Ignite 2.0, where this memory concept will become a default one.
Okay, and then the final question, Dennis, is there are some other questions, and the audience wants to know how they can reach you if they have any additional questions.
So actually, you can reach me over Apache Ignite dev list or user list. So send the message there. I look through the dev list and user list all the time, and I will be able to, I or someone else from the community will be able to reply on your questions.
Okay, well, that brings us a little bit over the top of the hour. I'm sorry if we didn't have a chance to get to your questions. I will make sure that I send these to Dennis after, and also you can reach out to him in the way he just described. Thank you so much, Dennis, for today's presentation. The feedback's been really positive. And audience, thank you so much for attending. We hope to see you on a future event.
Yeah.
Thank
Thanks
you again.
everyone for joining.